Hi, this is Mrs. Hoven going over Module 2, the basics. This is sheet number 1. Question 1 on each of your basic sheets will probably be a question about functions or relations. I'm going to let you know that every graph or set of points is considered a relation. I like to say there's a relationship, no matter if it's good or bad. You have a relationship with everybody. So all graphs and points will be considered a relation. So this is an example of a relation. This is an example of a relation. However, to be a function, if there is a graph, it must pass the vertical line test. This one does not. It actually, if I drop a vertical line, it will hit the C, which is my graph here, twice. So this is a relation, not a function, because you have points on top of each other. If you look at this one, the second one, you always look at just the x values when determining if it is a function. If you see two x values that are the same, like we do here, and they have different y values, it would be not a function. So if all the x values are different, then it is a function. If you have two that are the same, it is not. So yes, relation, but not a function. Next one, number 2. What is the domain and range of y equals x squared minus 4? You will need to graph it on your calculator and draw a sketch. So if I graph it on my calculator, which I'm going to do here, you can see it on my calculator, pull this into view. I'm going to hit y equals, and I have some stuff in here, so I'm just going to clear that out. Make sure it says equals. I'm going to do x squared minus, make sure you hit the minus key, not the negative, 4. And I'm going to graph. And I get a U that looks like it is 4 down. So 1, 2, 3, 4. Now, our calculators do not put arrows on the end, but if it runs off the screen, you assume that it goes on forever. So I want you to draw a sketch off to the side. The domain are all the x values, or how far right or left the graph goes. This graph right here goes forever left and right because of these arrows. Now you might be thinking, oh, it's only going up, but it's actually, all U's will get wider and wider and wider. So my domain in here can be anything. One way that they show that the domain can be anything is by writing it like this. This means x can be anything between negative infinity and infinity. Notice there are not any lines underneath there because you can't actually touch or plot infinity. So, other books may write something like this, all real numbers. These mean the same thing. I am fine with whichever one that you write. It goes forever left and right. If they ever give you points, though, and ask you for the domain, just simply say the x values. 1, 2, got 2 of those, so I'll just write 1, 2, and a 4 are your domain. Now range, those are your y values. That's how far up or down the graph goes. This graph goes forever up, but it does not go forever down. The lowest it goes is -4. So since range is my y values, it hits all y values greater than or equal to -4. It actually touches -4. That's the lowest it goes, and it goes forever up. If I asked you for the range of these points up here, you would simply say -6, a 2, a 4, and a 7. I usually put them in order from smallest to largest. That's why I said this one first. But on a graph, you have to look at how far up or down it is. Number 3, my next question is slope. This formula is on your formula sheet. It says find the slope of the line that goes through those points. So you subtract the y's. My y values are 6 and 4. And my x values are 8 and 7. And I get 2 over 1, or simply 2, because 2 divided by 1 is 2. Now I did my first y minus my second y. And if I do that, that's fine, as long as I do my first x minus my first x. Feel free, the formula is generally written with a 2 for using your second y. I'll do that one over here to show you that you get the same answer. If I go 4 as my first y minus 6, that's okay as long as I then do 7 minus 8 on the bottom, which gives me a negative 2 on top and a negative 1 on the bottom. A negative divided by a negative is a 2. Either way is fine. You pick which one you like. Number 4, and the last one I'm going to do on this video, is the one that's involved the most. It says write the equation of a line with slope 1/2 that goes through the point 6, 8 in slope-intercept form, point-slope form, and standard form. I'm going to start with point-slope form. That's actually written on your sheet really small. You will plug in the point for the x1, the y1, and the slope is the m. So I'm going to write y minus my y value that I'm substituting in is an 8, because that has y1 right there, equals my slope, that's my m right there, is 1/2, and then it's x minus the x value is 6. So that is point slope. Slope-intercept is y equals mx plus b. Again, you're going to substitute in your m, your x, your y, but in for the m, the x, and the y. The y was 8. The m was 1/2. The x was 6. And I had no idea what the y-intercept is. So 1/2 times 6 is 3. Then I'm going to subtract 3. And I'll get 5 equals b. If I have my m, or my slope, and my b, I can write my equation, which is y equals 1/2 x plus 5. I'll be honest with you, this is probably how you saw it done in your Algebra 1. Some students prefer to take this one and multiply it out. You'll get the same thing. They'll distribute y minus 8 equals 1/2 x. 1/2 times negative 6 is negative 3. And then they add 8 to both sides. Y equals 1/2 x plus 5. These are both the correct answer, gotten 2 different ways, so that is completely up to you if you want to find point, slope, and multiply it out, or you want to put it in slope-intercept form, plugging it in or substituting it in and then writing it. It's up to you. The last one is standard form. Standard form means put your x's first, your y's second, and your constant goes after the equal sign. There are 2 rules for this. A value must be positive, and your A, B, and C are supposed to be all integers. That means no fractions or decimals, although you rarely will see decimals in these, but no fractions. So what you do is you take your slope-intercept form, which I'm going to rewrite up here, and you need to move your x's first. So I usually circle them and draw an arrow to where I want them. So if they were positive 1/2 x, to bring them over, I would subtract 1/2 x. So I'll say it's negative 1/2 x. I did not move the y, and equals 5. Sometimes by just moving the x's you are done, and that's good, but my a value must be positive, and the a value is the number in front of the x. Mine clearly is not. To make that negative, to make that not be negative or to make it positive, I'll multiply everybody by a negative 1. So negative 1/2 would become positive 1/2. Positive y would become negative y. Positive 5 is negative 5. All right, one other rule is that there can be no fractions. Well, I have a fraction. To get rid of a fraction, you multiply by what's in the denominator of that fraction, which happens to be a 2. So if I multiply everybody by 2, 2 times 1/2 is simply 1, so it's 1x. If you don't want to write the 1, that is all right. That is assumed. 2 times negative y is negative 2y, and 2 times negative 5 is negative 10. So regroup. This one's point slope. This one, however you get it, is slope-intercept, and this one right here is standard form. Those are questions 1 to 4.